In this episode, we start building the kind of clear, calm explanation of AI models that lets an auditor ask sharp questions without getting pulled into hype or confusion. A lot of beginners hear the word model and picture something like a robot brain, or they picture a mysterious formula that only mathematicians understand. Neither picture is helpful, especially in an audit context, because auditing is about evidence, controls, and responsible decision-making, not about mystique. The simplest way to define an AI model is that it is a learned pattern matcher. It takes inputs, applies learned relationships from past data, and produces an output such as a prediction, a score, a label, or a recommendation. That is it. And that simplicity is powerful because it keeps you grounded when people describe models with dramatic language. Once you can explain a model as an input to output machine learned from data, you can immediately start asking audit questions about what the inputs are, what the outputs mean, how the learning happened, and what risks show up when people rely on those outputs. Clear explanations are not just for teaching. They are for control, because confusion is where risk hides. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful mental picture is to compare a model to a very advanced kind of sorting and scoring system. Imagine you have thousands of past examples, and you want a system that can quickly estimate whether a new example belongs in one category or another, or how likely something is to happen. A model learns from those past examples by finding patterns that tend to show up together, even if no human wrote those patterns down as rules. When a new case arrives, the model looks at the inputs, applies what it learned, and produces an output based on similarity and probability. In an audit mindset, that output is not truth. It is a guess with a level of confidence, and it should be treated as a decision aid rather than a decision authority unless governance says otherwise. This is why auditors care so much about what the model was trained on and how it was tested, because a model is only as trustworthy as the patterns it learned and the conditions it was evaluated under. When someone says the model is smart, an auditor translates that into a concrete question. Smart compared to what, in what environment, and measured how? To explain models clearly, you need to separate three ideas that people often blend together: the model, the system, and the decision process. The model is the learned pattern function that maps inputs to outputs. The system is everything around the model that collects data, calls the model, displays results, logs activity, and integrates with other tools. The decision process is how humans or automated workflows use the model's outputs to take action, such as approving a loan, flagging a transaction, routing a ticket, or recommending a product. In audits, problems often come from the system and decision process rather than from the model itself. A model might be accurate enough, but if the system feeds it wrong data, the outputs become unreliable. A model might be reasonably well tested, but if the decision process treats the output as final with no review, errors can become harmful outcomes. Clear language helps you locate where the risk lives, and that helps you ask better questions faster. The faster you can separate these layers, the more confident you will feel when an exam scenario mixes technical terms with governance issues. Now let's talk about what inputs and outputs actually look like, because this is where models become less mysterious. Inputs are the pieces of information the model uses to make its guess, such as transaction amount, time of day, device type, or customer history. Outputs are the model's result, such as a category label like suspicious or normal, a score like risk level, or a ranked list of recommendations. An essential beginner concept is that inputs are not always direct, obvious facts, because sometimes inputs are derived, meaning the system calculates features from raw data. For example, instead of using every individual purchase, the system might compute average spend over 7 days, number of password resets in the last month, or frequency of support contacts. Derived inputs can make models stronger, but they can also hide assumptions, and hidden assumptions are audit gold because they can lead to untested behavior. Outputs also need interpretation, because a score is not a decision by itself unless someone defines thresholds and actions. An auditor asks how outputs are used, what thresholds exist, and what happens when the output is uncertain or conflicts with human judgment. A term you will hear constantly is feature, which refers to an input element used by the model, whether it is raw or derived. Features matter because they determine what signals the model can pay attention to, and therefore what kinds of mistakes it can make. If a model lacks an important feature, it may ignore something that humans care about, leading to errors. If a model includes a problematic feature, it may learn unfair patterns or leak sensitive information through its predictions. In audits, questions about features often connect to privacy, fairness, and explainability, because features can be proxies for sensitive characteristics even when those characteristics are not explicitly included. For example, a location-related feature might indirectly correlate with socioeconomic factors, and that correlation can lead to uneven outcomes. You do not need to become an expert in statistics to understand this. You just need to understand that features shape behavior, and behavior shapes impact, which is why the selection and governance of features is part of responsible oversight. Another key idea is that models learn from historical data, which means they learn from the past, not from the future you wish you had. This sounds obvious, but it creates a powerful audit question. Does the past data reflect the real world the model will operate in? If a model is trained on data from a stable period and then deployed into a changing environment, performance can drop. If a model is trained on data that reflects past human decisions, it can learn patterns of bias embedded in those decisions. If a model is trained on incomplete or messy data, it may learn noise or misleading correlations. Auditors care because these are not just technical issues, they are governance issues. Someone decided what data to use, how to clean it, what to exclude, and what success means, and those decisions should be documented and reviewed. The model is therefore a product of organizational choices, and auditing is about evaluating whether those choices were responsible and well-controlled. To keep explanations beginner-friendly, it helps to group models by the kind of output they produce, because outputs are what organizations actually use. Some models classify, meaning they assign categories, such as spam or not spam, risky or not risky, or priority levels for tickets. Some models predict numbers, meaning they estimate a value, such as expected demand, likelihood of churn, or estimated delivery time. Some models rank, meaning they order options, such as which product to recommend first or which alert deserves attention. Some models generate content, meaning they produce text, images, or summaries based on prompts and learned patterns, and these raise special concerns because they can produce plausible but incorrect outputs. In audit thinking, the output type affects the risk profile. Classification errors can lead to missed threats or false alarms. Numeric prediction errors can lead to poor planning and financial loss. Ranking errors can create unfair access or poor decisions. Generated content errors can spread misinformation or expose sensitive data. When you can name the output type, you can quickly ask what the consequences of mistakes are and what controls should exist. A common misconception is that if a model is accurate in general, it is safe and reliable in all cases. Real reliability is more nuanced because performance can differ across groups, situations, or edge cases. A model might do well for typical inputs but fail for unusual ones, and those unusual ones might be the very cases where harm is most likely. Another misconception is that higher complexity always equals better performance, when complexity can reduce explainability and make oversight harder. Another misconception is that a model's confidence score always reflects real certainty, when some systems can be overconfident or poorly calibrated. Auditors do not have to solve these problems, but they do need to recognize them and ask for evidence that they were considered. That means asking how performance was measured, whether testing included realistic scenarios, whether there are thresholds for acceptable error, and whether there are controls for high-risk cases. Clear explanations prevent you from being impressed by performance claims without context. Now let's connect model understanding to audit questioning, because that is the practical point of this domain. A strong auditor question is one that is specific, evidence-based, and tied to risk. Instead of asking, is the model good? You ask, what is the model used for? What inputs does it rely on? And what outputs does it produce? Instead of asking, did you test it? You ask how you tested it, what data you used for validation, and what thresholds determined readiness. Instead of asking, do you monitor it? You ask what metrics you track, what triggers action, and who has authority to pause the system if outcomes become unsafe. Instead of asking, is it fair, you ask what fairness goals were defined, what tests were performed, and how disparities are handled when discovered. These are audit quality questions because they demand artifacts and processes rather than opinions. On the exam, the best answer choice often reflects this kind of questioning, even if the scenario uses technical language. If you think in terms of inputs, outputs, evidence, and risk, your answers become more consistent. Another essential concept is that models do not exist in isolation because they depend on upstream data sources and downstream consumers. Upstream dependencies include databases, sensors, forms, and external feeds that provide the inputs. Downstream dependencies include workflows, dashboards, automated actions, and human decisions that use the outputs. When upstream data changes, the model can behave differently even if nobody retrains it. When downstream processes change, the impact of the model can change even if the model stays the same. Auditors care because this means change management and monitoring must cover the full chain, not just the model. A beginner-friendly way to think about this is to imagine a thermostat that controls heating. If the temperature sensor is moved near a window, the thermostat output becomes misleading. If the heating system is modified, the thermostat might overcorrect or undercorrect. The thermostat model did not change, but the system context did, and outcomes changed. That is exactly how AI risk can emerge from dependencies, and it is why auditors ask about integration points and changes over time. Explainability deserves special attention because it is often misunderstood as a purely technical feature, when it is also a governance and communication need. Explainability means different things in different contexts. Sometimes it means being able to identify which inputs influenced a prediction. Sometimes it means being able to provide a human understandable reason that aligns with policy and reality. Sometimes it means being able to trace an outcome through data, model behavior, and process decisions to show it was appropriate. Auditors care because decisions must often be justified to stakeholders, and because unexplained decisions can be hard to challenge or correct. If a model affects people, a lack of explanation can become a fairness and trust problem even if performance is statistically strong. That is why governance often requires documentation about model intent, limitations, and appropriate use. On an exam, answer options that improve explainability and traceability often align with responsible oversight, especially in high-impact scenarios. By the end of this lesson, you should feel comfortable explaining what an AI model is in plain language, separating the model from the system and the decision process, and describing inputs and outputs without getting lost in jargon. You should also be able to use that understanding to form audit-style questions that seek evidence and control, because that is the heart of Domain 1A thinking. Models are not magic. They are learned pattern tools, and tools can be evaluated. When you treat them as evaluatable, you naturally look for requirements, testing, monitoring, and accountability, which are the themes that run through the domains. In the next episode, we will sharpen your ability to distinguish learning types in plain language, because learning type affects how models are trained, how they can fail, and what evidence is meaningful. For now, keep practicing one simple habit. Whenever you hear someone describe a model, translate it into inputs, outputs, use case, and impact, and the audit questions will start to appear almost automatically.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.